this is going to be the first video in a sub-series where we're going to start implementing some deep learning models. So we're going to start with the multi-layer perceptron. We'll do some convolutional neural networks, and we'll do some other methods as well, some unsupervised methods like autoencoders and stuff like that, generative adversarial networks and stuff like that. Okay, so deep learning is a subset of machine learning that uses deep neural networks to learn weights and biases that will seek to generalize based on a given input and predict an output. So deep learning has been widely publicized as being like one of the better methods in image recognition, natural language processing. So think Google Assistants and Alexa and stuff like that. So it's a good piece of knowledge to include in our machine learning tutorial. Some drawbacks are it does take a long time to train. So there's a lot of research in training these models and how to speed up training. Most methods use some sort of data parallel or model parallel sort of implementation. So data parallel is an example of, all right, you have your training data and you have 6 different copies of the same model. So you split your training data up into 6 copies, and each model trains on its own individual copy. You average those weights, and then you update the weights across all 6 models identically. So basically it's a way of training all the data in parallel. So that's called data parallel. Model parallel is when you have different aspects of your network across different pieces of hardware. So if you think like having a GPU for training a neural network, you're going to have some of your layers on some parts or on some processes on the GPU and other nodes on other processes in the GPU, and they're going to communicate between each other. So data parallel is more commonly used, but model parallel is also a method as well. But in this video, we're just going to have a light introduction to machine learning or deep learning. So we're going to use the Iris Setosa dataset to just validate that our model is working, then make sure that we got the code right, and then we'll use that use the code that we wrote to train a model to recognize the handwritten digits. So because it'll take a few days for the model to learn up to a given performance. So anyway, with that, we're going to get into this video by updating our data library to accept double arrays. So if you remember, the input array, the feature vectors for the MNIST dataset are unsigned 8-bit integers. So we just want to accept double types. We're going to have to figure out how to read a CSV file because the Iris dataset is a CSV. So if we take a look at if we cat iris.data, so we see that we have doubles, and then the class is at the end, and that's a string. So we're going to need to encode that into a number. So there's 3 different classes: Iris versicolor, Iris virginica, and then Iris setosa. Okay, so we're just going to have 3 classes. There's 150 data points in this data set, and they're split evenly. So there's 50 points of each class. Okay, so with that, we're going to jump right in. Be sure to like and subscribe, and if you like the video, please feel free to share. All right. Okay, so the first thing we're going to do is we're going to modify our data.h file, HPP file. So in that file, we need to add our double feature vector, and we need to add a class vector. So in a neural network, instead of having a singular output, you're going to have an array that maps to each particular output type. So since we have 3 different classes, we're going to have an array of size 3, and the class that that particular feature vector maps to is going to be set to 1, and then all of the other indexes are going to be set to 0. You'll see how we'll do that shortly. So I'm going to be working in Vim. I was using Visual Studio Code in the past, but I think Vim is a fine editor, and since we're going to be working a lot with the command line, I think it's going to be useful to do things this way. All right, so let's start by opening inside of data.h, and then we're going to also open the source file, so we don't have to, so we can see pretty easily what we want to update. All right, so we have this integer type feature vector, so I'm just going to copy that and paste it here, and we're just going to say double, and we're just going to say double feature vector. Set no wrap. All right, and then we need to also have the class vector, so standard vector of type int, and that's going to be a pointer, and it's just going to be class vector. All right, and then we just kind of need these getter and setter methods. So, and this is going to be a double. So set feature vector double, and then this is going to be a double that we pass in, and then we have a set class vector that's going to take in an integer for the count, i.e. the number of classes, and then we're going to have a standard vector double get double feature vector, okay, and then standard vector of int, and then that's going to be get class vector. All right, cool. So now let's jump over to the other file, and we have this set feature vector, so we can just copy all this, and we're going to paste that in, and we're going to say double, and whoops, double underscore feature vector, and then we're just going to have this append method that we can copy as well. And we need to, this is going to be a double, and we're just going to push back val, and it's going to be double feature vector. I know that's confusing, but I think that's a good way to implement it. All right, so now we need to implement the set class vector. So it's just going to be void data set class vector. Yep. Class vector, and that's going to take an int and a count. So what we want to do is we just want to say for int I is equal to 0, I is less than count, I plus plus. So if I is equal to label, so if we're at if the label, if the index is equal to the label, so in this case 1 or 2 or whatever, then we want to set that value to be 1 of the class vector. So we want to say class vector of I is equal to 1. But we also, I forgot, we need to actually set the class vector. So class vector is going to be equal to a new standard vector of type double, or type integer, sorry. And that's fine. And then otherwise, you can say down here, else, sorry, formatting, else we say class vector of I is equal to 0. Okay. All right, so that's all we need to do for that. And I believe that's all we needed to do for our data class. All right, so let's get out of that. And then we're just, so now we need to edit our data handler. So we need to implement a read CSV file. And then we also need to create a mapping of the classes as a string. So since the class names are a string, we need to map those classes to an integer value. And I think that's all we need to do for that. So we're just going to say vim dash o include data handler, and then source data handler. Okay, so I'm just going to say set no wrap and set no wrap as well in this other file. Okay, so in the data handler class definition, we need another class map. So I'm just going to copy this, and we're just going to say that the key is going to be a standard string. Okay, and we're just going to change the name to be a capital M. All right, and we need another method called void read CSV, and then we're going to take in a path, standard string path, and then a standard string delimiter. Okay. All right, and I believe that's all we needed to do for the header file. Yeah. Okay. So now let's jump over to this other file. So by the way, to navigate between two files in Vim on the keyboard, you just hit Escape, Control W, and then you can use the left or right arrow keys to go to another file, or Command W on a Mac. Or actually, it is Control W, sorry. So anyway, so let's implement this read CSV file. So we're going to say void data handler, read CSV, standard string, path, standard string delimiter. All right. So to read so first we need to set, we're also going to be counting the classes in this file as well, or in this function as well. So this is just going to be a general purpose, parsing a data file function. So we're initially going to set our num classes equal to 0, and then we're going to have standard if input file stream is going to be called data file, and we're going to pass in the path as a C string because that's what it accepts. And then we have standard string line, which is the holds each line. Okay. So now we're going to say while get line, or while standard get line of data file, and then we're going to put whatever we get into that line buffer, or line string rather. So then if we're just going to say if line.length is equal to 0, we're just going to continue, because we might get a line that doesn't have any length, and we don't want to have some issues when we parse our data. Okay, so then we're going to say data or d is equal to new data. So initialize a new data object on the heap, and then we're going to say d.set double feature vector, new standard vector type double. Oops. Okay, and then we need to say, so we have a new variable called size, or that of type size type. That's the position, so that keeps track of the current position. And then we have a standard string token, which is the value in between delimiter. Okay, so while position equals line dot find delimiter is not equal to standard string in pause. So like while it exists, while you have found a position where the delimiter exists, then we're going to set the token equal to line.substring from the 0th index to the position. So up to, but not including the position where that comma is. All right. So then we're just going to say d.append to feature vector, and then we're just going to pass in standard string to double of token. All right, we need to do some error handling there, but we're going to trust ourselves that it's going to work. So we're going to say line.erase from 0 to position plus the limiter dot length. So we want to erase the beginning of the string from the first index all the way up to the position where the end of that token is, plus the length of the delimiter. So that's basically going to remove that first token, and then it's going to shorten the array. All right, so then what this will do is it actually leaves the class as the last part of the line. So now we can say if class map.find of line is not equal to class map.end, which is basically saying if the class if we've already seen this class, then we're just going to say d.set label of class map of line. Okay. Otherwise, we're just going to say class map of line is going to equal to num classes and d.set label of class map of line, and then we're going to say num classes plus plus. All right, cool. So outside of that else statement, we're just going to append this to the data array. Push back D. Nice. So that's really all we need to do for reading in a CSV. And last but not least is we're just going to say feature vector size is going to equal data array at 0 dot get double feature vector size. All right, nice. All right, so that's done there. And then the next thing we have to do is we have to, in our count classes, so we're going to search. So to search a file in Vim, you just hit / and then the text you want to search for. So you're just going to say class counts, count classes. Yeah. All right, so see how it's right here. All right, cool. So so what we ended up doing is we're saying the number of classes is equal to the class count, and then we just set the class vector for each data object in that. Okay, awesome. And I believe that is all we needed to do. Yep. Okay, so now I believe, so let's just give this a try and see if it'll compile. So we're going to say clear, and then we're just going to say make. All right. So Clang's giving us a warning, and we have an error. All right, so it's saying that, oh, it's just set feature vector. So Vim source data handler, and then that's at line 24. Set feature vector. And then was there something else? Set class vector. So 189. Set underscore class vector. Nice. So clear, make clean, and then make. Ooh, yelling at me again. This is class vector of I. data.cc55. Okay, so vim source data.cc and 55. Okay. Maybe maybe I just have to say dot pushback or pushback 1. And that means I have to fix this too. Oops. Here, make clean. Oh, some more errors. What's going on here? Wow. So it's saying get double feature vector doesn't exist. So it turns out that I was actually compiling with GCC, but this is a C++ program, so I just need to add G++. And I just say make clean, and then I just run make, and there we go. Nice. So now that our code compiles, in the next video, what we'll do is we'll create our neural network directory structure, and we'll start implementing our header files. So with that, I hope you enjoyed this, and look forward to making the next part for you guys. All right, thanks.